So before I start talking more about Kubernetes, by the way, Kubernetes is amazing. Thanks, Tim, wherever you've just gone. That was awesome talk. Kubernetes is amazing. You should all use it. It's just totally, it blows my mind how awesome it is. We'll talk about that in a moment. But first, I want to start with a question. So as software developers, everything's getting more and more complicated all the time, right? Every year there's more stuff to know, more APIs, more technologies, more things to think about. On the client side, we have to do reactive material design, AngularJS 2, web workers, deal with every kind of responsive design, different form factors. We need voice, we need touch, and that's just the client side. Then there's mobile, then there's the software as a service, there's the server side, there's all this cloud stuff, and then all new APIs turn up and technologies, and it's really hard keeping on track of all this kind of stuff, right? It's kind of hard. So software is generally getting bigger and more complicated. It has to do more stuff, there's more features, there's more things. And coupled with that, we need to go faster all the time, right? We need to make bigger, more complicated, scary software, but we also need to do it quicker and go faster, which is kind of hard, right? And so the problem is, how do we go faster? Well, this is the microservices day, so the clue's in the title, really. Microservices is the way we're all thinking as an industry of a way of going faster. How do we deliver business value to our customers faster? So how does this work? So the first thing is, the first idea behind the microservices movement is split monoliths into small individual microservices, and the important point is they have their own independent releases, right? So part of it is a technical refactoring of software. The other part is a social refactoring of teams, right? The mythical man month says if you have a big team and you want to go faster and you add more people, it goes slower, right? You don't add more people to a big team to go faster. That's the worst thing you could do. So the kind of hack to get around this problem is, rather than adding people to a new team, you make new teams. So don't add more people to one team, make a new team, and make those teams autonomous, working on separate software independently, right? I'm not saying this stuff is easy, by the way, but if you really want to go faster, this is the only real way we've figured out in terms of the laws of physics and the overhead of human communication. The way of going faster is, rather than having one big honking monolith that you release as one big thing, have lots of little things that release all the time independently, and have lots of little teams that focus on each one of these things, right? Now, this is hard, right? This is really hard, but it's a balance, right? Do you want to go really slow with a big monolith that releases now and again, or do you want to go really, really fast with lots of microservices releasing all the time, right? The internet's a good example. The internet is a whole bunch of microservices, right? We don't take down the internet and bring up version 2, and we all sit there and wait while our Wi-Fi comes back. The internet is made up of lots of microservices that do lots of pieces of the puzzle, right? The open source ecosystem is a version of the social thing, right? Thank God there isn't one open source project that has everything in it. It would be a nightmare. Imagine the bike shed arguments of what color the thing is or whatever. But thankfully, the whole open source ecosystem is lots and lots of teams. Okay, some of them are actually huge, like Kubernetes, but there's lots and lots of teams. Some are quite small, some are quite big. Rather than scaling the open source movement, or the way of scaling the open source movement is have lots of projects and have each thing focused on one small piece of the puzzle, right? So that's kind of where we're going as an industry. It's seen as the best practice kind of thing. Refactor things into microservices, have lots and lots of little things that release independently, and on the flip side, have lots of teams that focus on one thing. Another part of the social thing, in many ways, a lot of this microservice and DevOps movement is more social, really, than technical. Traditionally, we used to have kind of developers, like in the old days, you'd be a developer and you'd hack like a war file and you'd chuck it over the wall, and then some poor operations guy would take it and think, well, I'll just try chuck it in my Tomcat thing over here, and you'd cross your fingers and it might maybe work, and you maybe had to set up some JNDI thing and a database connection factory here or there, and you'd make a typo on your JNDI name and it wouldn't work, and it was a kind of a nightmare, right? Because you had these silos of the developer chucks something over the wall, the poor ops person takes the war and tries to chuck it in an app server, and then you have the support people, and it was all a bit of a nightmare. The way of doing this better is to have one team that does the whole thing for a microservice, right? So one team designs it, tests it, develops it, and runs it, right? You do the whole spectrum in one focused team. So then one team understands everything about the microservice, right? You don't have these kind of Chinese walls where the ops people have no knowledge of what the code is or how it works. You try and have one focused team that can keep the entire microservice in your head, right? So generally speaking, the whole microservice thing is how do we scale and go faster, deliver business value faster? The downside is we've got all this stuff to manage now. We have all these microservices. How the hell do you do that? The last talk kind of gave the clue about how to do that, but we'll come on to that in a moment. The other thing that's kind of crucial, as soon as you move from having one, if you have like one monolith, you can probably figure out how to automate that one release. And it could be held together with string, and you might have one guy who just does the release or whatever. As soon as you move to having tens, hundreds, thousands of microservices, you really want to automate the crap out of everything, right? You want an automated way of doing builds, tests, deploys, running upgrades, right? You want to automate the entire pipeline for all of your microservices because you're going to have lots of them, right? You don't want to build by hand every one of those builds for every one of those microservices because you're just going to be in like DevOps hell just maintaining all this stuff. So invest time in automating all of your deployment stuff. Okay, so let's talk about how we do it. Well, Kubernetes. We've just seen an amazing talk on Kubernetes. Kubernetes is amazing. For me, it's the ideal microservices platform, right? Why is it? Well, for me, the biggest thing, you can look at Kubernetes as like an infrastructure thing. It's like containers as a service kind of thing. For me, it's about developers. The reason why I'm a developer, right? I hack code for a living. I love Kubernetes because for me, like OpenStack, sorry, any Red Hat sales guys in the room, OpenStack bores me to tears as a developer, right? Yeah, whatever, I don't really care. Infrastructure as a service, OpenStack, it does nothing for me, right? Because it's just VMs and stuff. I mean, who cares? Kubernetes, it's about developers. It's a self-service platform that developers can use to get actual stuff done, right? It's targeted at developers. So it allows developers to have their own cloud that they can just poop stuff out and experiment and run tests, run integrations, validate stuff. I don't need to keep raising support tickets saying, please, can someone spin me up a VM somewhere for me, please, possibly. You as a developer have a CLI tool, a REST API, you can program it. It's a self-service platform that developers can just get stuff done, which is really, really powerful, right? It kind of changes everything. The other reason it's kind of awesome is namespaces. We didn't talk about it in the last talk too much. There's something called a namespace in Kubernetes. Namespaces allows you to, rather than everybody being inside the same logical environment and kind of potentially kind of breaking each other's stuff, namespaces allows you to segment things, right? So each microservice can have multiple environments that it can operate within. So you might have 10 microservices, and each microservice team can have 3 environments for maybe testing and staging and production. So namespacing allows you to segment all your work, and so you can just focus on the piece of the puzzle you care about, right? So the combination of all the core abstractions of Kubernetes plus namespaces leads to just awesome. It's the best place to work with microservices around. It's amazing. It truly is. So what I wanted to do, we have an excellent, the first talk today was an excellent overview of what Kubernetes is. What I want to focus the rest of the talk is, if you're a developer, what does Kubernetes look like? Or how should you approach working with Kubernetes? I've been developing on Kubernetes now for about a year, and it's heaps of fun, right? I don't ever want to go back to anything else. It's just amazing. So I want to give you a few insights as to what it's like to work with Kubernetes, what you need to focus on. One of the kind of problems of Kubernetes in many ways is it does so much awesome things. I mean, I'm sure Tim could talk all day about stuff it does and features and cool stuff you could do. I think part of the problem as developers is you can kind of blast this huge, you see this huge scope of stuff, and it can sometimes be a bit hard to figure out what does a developer do, right? If you're a Java guy and you're trying to write a web app, how do you use Kubernetes? So I just want to echo what Tim was saying. Really, as a developer, if you're writing some code and you want to do stuff on Kubernetes, all you've got to do is figure out these 3 things: pods, replication controllers, and services. Now, if you're a Java, how many people do Java in the room or develop Java? Oh, thank God for that. Few. Okay, there's a few of you. Oh, my talk was going to be a disaster. Okay, a few. So if you're a Java person, like most Java people are writing, say, web app, you might write a war or something like that, or you might use, you write REST or Camel or Java EE or whatever. In many ways, if you're a Java guy, you can kind of squint, and when you hear pod, just go, oh, yeah, that's like a JVM, right? So for most Java guys, a pod would be just a JVM in a Docker container. You might one day want a sidecar container that does something funky, like pull down files or do git clones or do something kind of weird. But mostly a pod is kind of just think it's like a JVM, right? That's your JVM. And as a Java guy, all you really need to focus on is environment variables, ports and volumes, maybe secrets one day, but don't worry about that for now. But mostly it's about volumes if you need persistent state. A lot of Java applications are stateless usually, right? Most wars, they're just a web app. They talk to some persistent backend. So most of the time, you don't even have to worry about volumes and state, which is even nicer. So for a Java person, it's usually just environment variables. Often you're using something like Tomcat. Well, the ports are already figured out for Tomcat, so you don't even need to worry about that. So it's mostly environment variables is all you probably care about. Okay, so pods, just think JVM. Replication controller, as Tim was saying, it's just a way of replicating pods to create a number of instances of pods. So to say in Java speak, It's like saying, how many tomcats do you want to run? Or how many wildflies do you want to run? 6, 5. And at any point in time, dial up and dial down. Kubernetes lets you do manual scaling. You know, I want 6, I want 5, I want 3. You can do automatic scaling in 1, 2, I think it is, where you can use metrics to scale up or scale down. You can also write your own autoscaler, right? It's pretty simple stuff. One of the things, I mean, Tim said all this already, one of the things I love about Kubernetes is you can just build on top whatever you like, right? Nothing's hidden. Everything's a public standard REST API and CLI. So you could write your own load balancer, you could write your own autoscaler, you could write your own manager. It's pretty simple stuff. So if you have some magical way to know when you need another Tomcat by, I don't know, looking at a global metric of trades going through your trade database or whatever it is, right? You can look at your magic SLA number and go, I'm going to scale up now. And you can write, 10 lines of code to scale up or down. It's really, really simple. One of the things I've found is whenever you kind of think you've hit a limitation with Kubernetes, it's really trivial just to write your own stuff if ever you hit your head on something, right? Like, if you don't like the load balancer, well, just write your own. It's simple stuff, right? It's really, really simple. I know it might sound scary. It's honestly really, really simple. Because Kubernetes gives you all the information to just monitor all the available pods and so on and so forth and just write your own stuff. So don't worry, relax, enjoy it, and just have fun on it. It's awesome. So here's an example of, you can't read it, don't worry about that, but it's just, this is a replication controller. Just think of the shape. It's like some YAML, it's got a shape, it fits on the slide nearly. Look, there you go, it fits on the slide almost. And basically it's just, Docker image with a version, a couple of environment variables, and a couple of ports, and you're good to go, right? It's really, really simple. So that's replication controllers. Services, the last talk really described services really well. Services is just a way of exposing a port that's in a container or in a JVM. So, for example, exposing your Tomcat as a URL that you can then invoke, right? Really, really simple. A couple of things about services. A service could be internal to a Kubernetes cluster, right? By default, the portal IP address is an IP address you can only usually see if you're inside Kubernetes. So your web browser usually can't resolve that IP address. So if you take a service IP and put it in your web browser, you probably can't get in because that IP address only exists within a Kubernetes cluster. So then you have external URLs or domain names for external access. We're using external load balancer, right? On GKE, it's got its own load balancer. On OpenShift, there's HA proxy, which does the same kind of thing. So you can have internal and external service addresses. The other thing that's interesting about services is Kubernetes basically is a service registry for everything your microservice needs, right? If you're writing a service, even if it's a macro service, any service, whatever service you write, you probably need to discover a database. You probably want to discover a message queue or a memcached or Redis or whatever stuff you're using, right? You need to discover those things. Not everything will always be running inside Kubernetes. So you can have external services that are hosted somewhere else, right? You might have a database that's on, I don't know, OpenStack. You might have a software as a service thing that's on the internet somewhere magical. Kubernetes has services which can be internal services inside Kubernetes, or they can be external. And it's pretty trivial just to write a little blob of JSON to register any service in Kubernetes. So basically, Kubernetes is a really nice service registry. When I say service registry, please don't think like UDDI or anything like that. It's like a nice service registry that's a joy to use, right? It's something that it puts a smile on your face every time you even think about it. Unlike UDDI, I think that's a different reaction when you. For those people who use it, you maybe don't smile when you think of UDDI. Anyways, I'm sure some people like it. Sorry, sorry, Kurt. I forgot you were here. I love UDDI. It's awesome. It's really, really awesome. Never say a bad word against UDDI. Okay, here's how. Moving swiftly on. Sorry, I'll buy you a beer later. Here's how you could do service discovery in any programming language, quite frankly. You can either use DNS names to access services, or you can use environment variables to access services. One of the things that's really, really nice is there's no like API you need to look things up, right? You don't have to use some REST API to do a query on startup to find out where things are, and then keep querying in case they change. The service registry in Kubernetes gives you basically an IP address or a host name to access a service which is constant for the lifetime of your system. So whether using DNS names or environment variables like this, you do that once on startup, you can then talk to the service for the lifetime of your program. You don't have to worry about things moving or changing, right? And during the lifetime of your microservice, all the things you're consuming might come and go, the pods might start and stop. You don't really care about that because you're using the constant service IP all the time. So service discovery rocks in Kubernetes. The thing I kind of really like the most about Kubernetes really is it's kind of invisible magic, right? As a programmer, you don't really see it. You just use a couple of environment variables or a DNS name, and magic happens. You don't have all these big, fat APIs to worry about or comprehend, all these complex class libraries to work out. It's a couple of environment variables or a couple of DNS names, and everything just kind of works. It's truly quite a magical thing. Okay, so that's service discovery. So just remember pods, JVMs, replication controllers to scale up and down, and services to discover things and to load balance across things. And if you can get your heads around those three things, you can do truly amazing things on Kubernetes. It really is just amazing, right? It's the perfect thing for microservices or cloud-native applications and so forth. It's truly awesome. Right, I want to change gears a little bit now. Oh, yeah, I should say, if you're building a microservice on top of Kubernetes, then really you're writing a replication controller that has a pod template inside, JVM. And you usually want to make a service. Most times you make a microservice, you want somebody to be able to invoke your microservice, so you want to make a service definition. Overloaded phrase service there, unfortunately. But in other words, a blob of YAML or JSON that defines the ports, right? And that's pretty much it. Okay, so as a developer, this is kind of your workflow. You write some code, you put that code in a Docker image, you create some Kubernetes metadata, a blob of JSON, a blob of YAML, whatever. You apply that metadata to an environment using, say, a kubectl or whatever. And then from that point on, you resize, scale up, scale down, and you do rolling upgrades and things like that. Continuous integration and continuous deployment can automate everything apart from the top line. Unfortunately, you have to do the code bit yourself. We're working on it, but you have to do one thing, okay? Everything else we can automate, and there'll be a demo. James is going to do a demo to show how all of that can be automated apart from the first line. So you do the code bit, and then everything else should just kind of automate, which is cool. Right. Tools, you saw lots of examples of the kubectl tool, so I won't talk much about it. It's really simple, it's really elegant. Once you get the knack of querying for resources in Kubernetes, and deleting them, creating them, scaling them, and so forth. It's really simple to get your head around, and then you can work with anything inside Kubernetes. So you start with pods and services. Eventually, you might work with secrets and volumes and service accounts and other kind of more complicated bits. But it's one of the nice things is the REST API is very RESTful. So once you've understood how to work with, say, pods, you can work with any of the resources. Really, they're just slightly different shapes of YAML, really. So it's nice and simple. I'd just like to mention the Fabricate project. So the Fabricate project is something I work on mostly. It's got a nice robot logo with a fire in its belly. And it's juggling containers. Yeah, cool. Basically, the Fabricate project does a whole bunch of different things. It started off as an integration platform as a service, which is a bit of a mouthful. In other words, the initial goal of the project was to make integration and appliance on top of Kubernetes. So if you want to create APIs with API management, if you want to deploy, say, Apache Camel integration flows, it should just kind of work, right? You should just pop your integration code in the cloud and it just kind of works. So the idea is to have a self-service integration platform as a service that it just kind of works. You don't have to worry about programming so much. Everything's in the web browser. It's kind of a web-based integration platform. Along the way, we realized that we need lots of other stuff to make that happen. Management, particularly a console so you can see what the hell's going on and visualize things and comprehend things. Centralized logging and metrics. Jimmy's going to do an amazing demo later today if it works, if he can find power, of basically centralized logging and metrics so you can visually understand what's going on in your system. Continuous delivery turned out to be quite a big one. One of the biggest issues with doing integration as a platform is you want to move code through environments, right? Traditionally, the platform as a service model is you clone a Git repository, you kind of hack on some code, and you Git push it back, and then it redeploys the containers. Most people in the integration space, you probably don't want to push to production every time you do a Git commit, like not right away. You might want to like test stuff a bit, I mean, I'm sure you're amazing, but we all make mistakes. So what you probably want to do is push and then have a system test run or a load test or a soak test or a user acceptance test. You might want to run some sample data through to check you haven't made a typo on your XPath, which most people usually do all the time. So you probably don't want to go Git push straight to production. You want to kick off a pipeline that does various different things along the pipeline. And we'll show you those in James's talk later. So fabricators end up doing all of this stuff, right? It was trying to just be an iPaaS, but it's kind of does all these other bits and bobs. So the first thing I'll just mention is a console. I might do a very quick demo of the console. You won't be able to read anything on this slide. Don't worry about that. Just look at the pictures, really. It just looks cool. But the basic idea is to help you see. So imagine you're a microservice developer. You're on a small team. There's like 5 of you. You're sharing 2 pizzas and having fun. And you're developing this microservice. You're probably going to have multiple environments where that microservice lives, right? You're probably going to have like a test environment where your system tests run. You're probably going to have a staging environment where the last good build is running, so you can just kind of tinker with it and play with it and try it out. And then you probably get, well, hopefully there's production at some point in the lifetime of it. And you're probably going to spend your time looking at the whole list of environments, and you're going to keep focusing on where the pipelines are at, right? So on this screen we have environment, testing, staging, production. For each environment, we can see what version of software is running, what was the build that created it, what was the git commit that is running in that environment, and then how many pods are running. The next bit down is the pipelines. What active pipelines are running right now? Depending on how many commits you do and how long your testing pipeline is, right? You might have a soak test that runs for 3 days, right? Or your integration test might take an hour. Depending on the length of your pipelines, you might have lots of pipelines running concurrently, right? Every time you do a commit, you're going to do a new release. That's going to go through your pipelines of testing, integration testing, soak testing, user acceptance testing, and then hopefully eventually production. Anywhere along these pipelines, you might have human approval, so something might sit at the approval stage for like a week, a day, an hour, whatever. So you might have multiple of these pipelines that you can see them moving through, and then at the bottom you've got the log of the last pipeline that's running. I might do a quick demo, and I'll just play this video. This video is a quick demo that shows one change happening. So we're using the Fabricate console. We're going to edit the source code. You won't be able to read anything. Don't worry about that. We're going to edit some source code in a Java project. Just look at the pictures. It just looks cool. We're going to edit some Java code, which you won't be able to read. And we're going to type awesome. There, we've typed awesome, and we're going to save it. So this is basically a web-based IDE that lets you browse the source code. And when you save it, it does a git commit and a git push into the Git repository. So we've just done a git push to make the code change. In a moment, that will then trigger a webhook in Jenkins, which then triggers a Jenkins continuous deployment pipeline. That pipeline is then going to kick off a release. You can see the release has just started. That yellow box has just started. That's the first stage of the new pipeline. We can watch the release at the bottom. It's not very interesting, but you can see it kind of fly by. What's basically happening now is it's going to make a new version of this software. It's going to rebuild everything. All the jars are going to be put in a Nexus repository with a new version number. That's going to take a few moments. You can just see it's uploading there to Nexus. Once that happens, it's going to run the integration tests. I'll talk a bit more about integration testing in a second, but it's basically going to use one namespace and one environment to run all the integration tests or system tests. If those are passed, so the integration tests are running right now, you might see some flicker in the testing environment in a second. Once the integration tests are finished, it's then going to stage it. It's then going to go in the stage environment. You won't be able to read this, but right now today it's 106 is running in the test environment. It's just built 107. It's just entered the testing environment. It's just gone green. So 107 is now in testing. That's now passed. It's now staging to the staging environment. Good name, that. And 107 is about to go live. We should see a running upgrade happen fairly shortly, hopefully. Hopefully. It's a video. Of course it's going to happen. So any minute now, the running upgrade will happen in the video if I remember what I recorded this morning with the jet lag and the mad cow. So there you go. There's the running upgrade happening. So you see the grey things just started, the little grey dot. That's the pod that's starting up. There's a readiness check that waits for the pod to really start. So they're starting the process, and then is the JVM ready to actually process camel requests and so forth. And then you see the old one fail, so the old one's been killed. So now 107 is now in staging. It's now waiting for approval. We're using Jenkins approval, and so I just approved it really quickly through the Jenkins log. We have much cooler ways of doing approval, which James will show you later, hopefully. And then now the promotion should happen to production, right? Now, don't worry that you can't read most of this, but the important thing is, from one screen, we can look at the entire life cycle of what's going on. We can watch what's happening on our project. We can dive into the source code. any environment, we can instantly see which version is running, what's the git commit for the source code that makes it, and what's the build that created it. Like sometimes the builds go a bit weird and strange things happen, so you want to see why did the build in production different to the build in the staging and so forth. So all of these are links, by the way, so that you can just dive in to the replication controller in any environment, to the pods in any environment, to the build, git commit, and source code and build logs. So from one small, simple-ish view, which unfortunately you can't read, you can basically dive into everything that relates to your project, right? So as someone on the microservices team, you can just sit in this console and just dive into whatever you need to look at, right? It's really, really nice. Sure. Oh, you're there, sorry. Yes. You can do whatever you want in your pipelines, right? You could have one pipeline triggers other pipelines. So you could have one machine in production that runs the production deployment that runs as a production user that developer can't access it, right? How these pipelines work, well, James is going to talk a bit more about this, but in essence, the pipeline can do whatever you want it to use and do. You could have different Kubernetes clusters for production. You can have a different Jenkins server that does... Yeah. Each one of these, in what way? Is it partitionable? Yeah. All right. Let me explain the screen a bit then. This screen is a screen that shows each project, and each project can have whatever environments it wants to see, right? So one project might just have test. One project might have test, production, staging, load testing, soak testing, whatever. So each project can define what environments it has. And each project can create its own pipeline. And each pipeline could be anything, right? You might only see soak testing and load testing, right? And someone else might use a different project to do production. How you refactor your projects is like a social thing. It's up to your teams and how you want to work and whatnot. You might have developed for security clearance. You might not be allowed to see certain environments and certain logs and yada, yada, yada. So you might have a non-secure project that like people like me get to play around with, and then you might have like secret spook ninja projects that you know they're allowed to see stuff like that. So how you slice and dice this, it's totally up to you, right? It's easy, it's simple. You can define the pipelines, you can define whatever environments you want, and you can show or hide environments however you like, right? So it's totally up to you. This will be a bit more clear in James's demo, but this was just a quick intro to the kind of visualization we can do where you can just see the stuff that the team should be working on and see what's happening, right? Okay, let me switch back to the presentation. How long have we got left, by the way? A couple of minutes. Okay, quick. Okay, a quick bit about the Java tools we have. What we've really tried to do is make it really trivial for Java people to just migrate to Kubernetes as painlessly as possible, right? We don't expect you to do a total greenfield thing, ditching all of your code and starting from scratch in Golang or anything. We assume you're just going to take your Java stuff and make it work on Kubernetes. So we've built a bunch of tools to help really customers just migrate to Kubernetes. The first one's a Maven plugin. I don't have much time to go into much detail, but most Java people use Maven. So we've got Maven plugins to generate Docker images, Maven plugins to generate the Kubernetes JSON. One of the things we found was making the Kubernetes metadata by hand kind of gets boring really fast because it's really easy to make a typo, especially with there's lots of labels that get replicated all the way through the blob of JSON. So we have a little fabricate JSON goal that will just make you some JSON that it guesses what you need and just generates that for you. You can then override that and tinker with it with Maven properties or tinker with your POM to update that. If you really want to go to town and do some really wacky stuff, there's a type-safe domain-specific language in Java that lets you add like a new service account or a custom wacky service or whatever. So you can mutate the default, but you don't have to sit there and write the whole thing by hand. It will just generate it by default. And finally, there's a fabricate apply that lets you just apply the JSON you've generated in any environment you like. So if you're a Java guy, you can just sit in Maven and just do everything you need to do, and you don't need to worry about all the Kubernetes stuff. We kind of hide that stuff from you. Anybody use Spring or CDI? Okay, few. Okay, good. If you're using dependency injection, you often want to dependency inject services, right? Your database, data source, JDBC, data source, connection factory for JMS, all of these kind of things. These you want to dependency inject objects which refer to services on the network somewhere. So we basically have an annotation at service name that lets you inject any service in Kubernetes for you, and it does all the kind of the magic and the lookup and the DNS, all the environment variables and all that kind of stuff. So the first example, we give it the service name, the Kubernetes service name, which is lowercase letters with dashes and dots. That will then inject the real URL to access the service. So it's really, really simple. The second one is slightly more complicated. We're saying, I want to inject the external URLs because I might want to pass that in a web browser or something, or render it on a web page. So we're saying, give us the externally accessible version of the service with the @external. And we're saying, please use HTTP as a protocol. Sometimes people use wacky ports on their service for whatever reason. So the port might be 9,200, which it's hard to work out what protocol that is. So here we're saying @protocol. The third one is if you want to do that wacky DIY load balancer. You can inject a list of all of the service endpoints, so all of the URLs to talk to the individual pods. We can inject that as a list, and you can then do your own load balancing on the client side if you really want, right? To be fair, there's not a huge need to do this, but if you really want to do it, knock yourself out. And that list is then kept updated in real time. So as pods come and go, that list is added and removed in real time. So you have an in-memory linked list of all of the URLs of the service. So that's nice and simple. System testing and integration testing. When you saw that system testing kind of thing go green before, what it was doing was running this. So this is, how many people have used Archillion before? Archillion? No, a couple of people? So Archillion came from JBoss folks, and it's a way of doing in-container testing. So if you write like a jar or a war, running it on your laptop kind of naked is different to running it inside, say, Tomcat or EAP or Wildfly or whatever. So Archillion started as a way of testing your deployment unit inside the application server of your choice, right? What we've done on the Fabricate team is we've made Fabricate Archillion, which is an Archillion plugin. And what it basically means is it takes your Java code that's inside a Docker image, and tests it inside Kubernetes for you. Now, I really want to emphasize how awesome this is, right? As Java folks, we're kind of used to thinking, well, Java runs anywhere, right? So let me just run it locally on my Mac on, say, OS X or Windows. When production is probably going to be, say, Linux, right? So we should always be running things on the production environment or the production-like environment because you're not really testing the same thing, right? Different operating systems, different network stacks, different thread protocol-y things. You're going to have differences, right? So spend as much time as you can running on the real deal environment that's going to be in production. And don't waste time running things outside of Kubernetes. Unit tests, knock yourself out, right? JUnit rocks, unit tests up the wazoo, that's all cool. But as soon as you move beyond unit tests, it's better to run just inside Kubernetes. It just saves a lot of time. We wasted a lot of time trying to run outside Kubernetes, pretending we were in Kubernetes, and it's a waste of time because you're not really testing your Docker image, and you're not really testing your Kubernetes metadata. So what Archillion does what our Fabricate Archillion does is every time you run this is a JUnit test case. You won't be able to read it, don't worry. But it's basically a page of source code, which is JUnit. When you run this test case, it spins up by default a brand new Kubernetes namespace, provisions all of the different Kubernetes resources you need, all the replication controllers and services and whatnot, then asserts everything starts up, and then runs your JUnit test case code. This exact test case, what it actually does is it provisions an ActiveMQ broker, a producer, and a consumer. And then it asserts that everything starts up correctly, and you haven't messed up your JSON or messed up your Docker image. And then at the bottom, it does assertions using JMX queries over HTTP using Jalokia. And it asserts, the first assertion here, asserts that the camel consumer starts. The second assertion there, the second to last line of Java code, which you won't be able to read, that asserts that the, what does it assert? It asserts that the message queue has at least 1,000 messages enqueued to it. In other words, that the producer manages to produce its messages. And the final assertion asserts that the consumer dequeues the messages. Yeah, question?
In this particular example, or in the framework that you have here,
Yeah.
code deploy all this into one
namespace.
multiple containers?
They're all individual containers, but it's all within one namespace, right? So you can have as many containers of each, right? You can say I'll have 10 brokers, 5 consumers, 7 producers. Have as many instances of all the containers as you wish, right? Every resource is a separate container, right? So your brokers is a separate containers, your producers separate containers. So it's basically testing your Docker images and your Kubernetes JSON. So it's basically running pods, right? It's running pods and replication controllers and services. You define how many instances of each you wish. And it asserts all of those things you've said to run starts, which even that is actually a pretty good test because There's liveness checks in Kubernetes that checks, I know the process started, but is it actually really doing anything? Like, can you ping a magic URL, or can you query a JMX MBean to see if it's there, whatever. So just testing things start is actually a really good system test, because it's surprising how easy it is to mess up the JSON file. So it's testing that, and then once that happens, you can knock yourself out and do whatever you want from that point on. You can query what's running, interact with things, send messages to things, flood the message with sample data from a canned database or whatever. So you can write any integration test you wish. What the Archelian stuff is doing is automatically provisioning everything on a new namespace in Kubernetes for you. So it's taking your Kubernetes resources, your Docker images, anything you like, provision them on Archelian, on Kubernetes in a namespace, and by default it makes a new one each time and then tears it down again. You can say, always use this one over here, please. You can specify that if you wish. So that's basically what it does. Does that make sense? It's really, really useful. Once you start doing this, you realize, why didn't we always do this for all testing ever? Like, provisioning stuff is kind of hard and it's painful. It's now pretty trivial in a bit of Java code to provision whatever environment you wish, right? Have a canned image for production database, have, well, maybe not real production data, have canned reference data, have canned services, just provision them, run whatever tests you wish, and then check it all works. You maybe can't read it at the bottom. We've got various libraries that do assertions for you. So there's assertion DSLs for asserting that certain pods are live and don't die, or certain things stay up long enough, and asserting various things over JMX. Okay, I'm wrapping up. One quick thing to mention, by the way, is people in platforms as a service, we often think about the post-commit and the post-push lifecycle. In other words, I've done a code change, I've done a git commit, and I've pushed, and all this magic happens with continuous integration and continuous deployment, and that's all cool. One thing I'd just like to mention, as soon as you start working with Kubernetes, really focus on the pre-commit workflow, right? One of the whole points of this microservice thing and this Kubernetes thing is we want developers to go faster, to deliver value quicker and faster. It makes everyone happy, right? Part of that is the pre-commit thing. How does a developer hack their code so they can try it out before they commit? I don't know about you, but I like to check things, vaguely work before I push. I know some people don't believe that in this room, but I do try and make it work before I push. I try, right? I'm very trying. So now, at first it might seem a bit hard, like how do we do the pre-commit thing? Because most things happen after the commit. So one thing that we found on the Fabricate team is you can run, okay, get ready for this. You can have a VM, right? You can have a VM that's like an app server, right? It's a VM, and it's got Kubernetes on there, and it's got Docker on there. And you can think of it as like, like if you're making a war, you'll run like a Tomcat or a WebLogic. Well, nobody does that anymore. A Wildfly or a Tomcat, and you'll deploy your war into it, right? And you'll keep this app server running, and you'll run it locally, and you'll deploy your stuff, right? You can do the same thing with a VM that's got Kubernetes and Docker inside, but you don't deploy the war, you deploy the Docker image in there, right? So you can have your own, basically, standalone Kubernetes on your laptop. You can deploy your app in there by basically just doing a Docker build, right? And then use it in Kubernetes. And if you squint, it's like an app server. It's like your personal app server kind of thing. And as a Java developer, it feels kind of the same, right? But the thing is, you're then testing the real Linux, the real containers, the real Kubernetes, the Kubernetes services. You're testing the real deal that would be the same as production, right? Which is a huge, huge difference, right? You're not testing your locally installed version of the app server, which may or may not even be the same version as what's in production. You're testing the real deal, right? You're testing the real stuff on your laptop, so that really, really helps. One last thing, and I really should wrap up. One last thing. You want to go faster, so you want to be able to write some code and see it live in your Kubernetes cluster, like really, really quick. Docker build is fairly quick. One of the slowest things with Docker is doing Docker push, right? Pushing and pulling from Docker registries is really sucky and slow. When you're working locally, you don't need to push because you've only got one node, so you can just do a Docker build it in the Docker daemon that's on your laptop. You don't need to push anymore because the image is now in that Docker daemon. So you can avoid the pushing, so that's cool. But still, Docker build, you're basically making a big tar of all the jars you need and posting it to Docker. What's cooler is if you do that once, but then you watch. If you change one library, just copy that one library across. Do incremental changes. So rather than copying a 80 megabyte tarball over to Docker, just copy the one jar. So there's something called Docker Watch, which watches your local Maven repository. And any jar you rebuild, which your IDE can rebuild on save and all that kind of stuff, anytime you rebuild one jar, it copies that one jar into Docker. So that's really cool. What's even cooler, though, is OC Sync. So OC is the command line tool for OpenShift. OC Sync has come in upstream in Origin in 107. OC sync basically does rsync from your local file system into a Docker container. So it does binary diff changes. So if you change one line of code, it diffs the bytecode and sends the differences in bytecode to the container. So you get crazy fast changes in the Docker image. The only issue is, if you haven't bought JRebel, you probably have to stop and start the Docker container, which is fairly quick, but sometimes the JVM takes a little while to kind of get going. But we're aiming for like super crazy fast round trip, so you can write some code and it just works locally, right? We're working on a lot of Eclipse tooling to help automate all of this too, but it's definitely worth investing in. The more you can optimize your pre-commit workflow, the faster your developers can get feedback before they commit. And then after the commit, do all the CI, CD stuff that James is going to talk about later. So in summary, which I should have summarized a while ago, but better late than never, if you're using Java, use the Maven tooling. It just saves a lot of time and effort. It's really, really simple and tries to automate everything. If you do dependency injection, then @service_name is your friend. That injects all the Kubernetes services. Please do system testing in Kubernetes. System testing, load testing, integration testing, soak testing, whatever testing you like. Do it in Kubernetes and use Fabricate Achillean, which is really, really awesome. Optimize your pre-commit, and please use CI/CD. Go to James's talk for sure this afternoon and see how all that stuff works. Thank you. Any more questions? I'm here all day. Come and grab me if you ask any more questions. Have we got time for any questions? Probably no. We don't have time for questions. I apologize.
But James is around.
But I'm around all day, so come and grab me if you need any help on anything. Thank you very much. Cheers.